For 2 days we've been talking about arithmetic and geometric sequences, and we learned that arithmetic sequences behave like what kind of functions? Linear, good, linear, and that geometric sequences behave like what? Exponential, good deal. So we are doing all of this. We are leading into actually talking, I mean, we talked about linear for a long time already, leading us into talking about exponential functions. But we're going to make a connection today, which I slightly mentioned as we were going through the other stuff, but a connection between these actual functions. Because remember, you do not get a reference chart. You are not going to get these arithmetic and geometric sequences formulas, but that's okay. As long as you can make the connections, you'll be all right. So when we look at this form of the arithmetic sequence formula, I believe I did try to make the connection with you that it is basically slope-intercept form. But this isn't the way you're used to seeing slope-intercept form. You're used to seeing it as y equals mx plus b, but I don't think switching the two terms around is that taxing on your brain, hopefully. Where your y-intercept, that is your initial value. That's what happens with the line. And then d is basically your slope. Okay, so if you can connect those, you can kind of see how that works together. But remember, if you're only going to know one of these two, this is the one to know because it works for everything. And you have to know point-slope form. Now, some of you still don't, but you should and you have to. So if you can, then you connect it to this. This is not the way that you're used to seeing point-slope form either. The way that this is taught to you is first with y minus y1 equals m times x minus x1. Okay, that's how you first see it. And you can substitute your stuff in there and be done with it. But then we get to a point where we go, okay, this is all fine and great, but what we really need a lot of times is for it to be y equals, so all we need to do is move that y1 over. Thank you. And this would give me y equals m times x minus x1 plus y1. And when we're just talking about writing equations of lines, some of you might feel more comfortable still doing this and then moving it over, but some of you might, because then you don't get your minuses messed up, and some of you might feel fine going directly here. Either way, it doesn't matter. But if you notice this one compared to this one, the only difference is f of x is y, and they just put y1 in front. Otherwise, it's the same, okay? And then when we connect it to this over here, your, so over here we have xy's, right? That's what we're using. xy, and then x1, y1. Those are the things that we use. And then over here, instead of x and y, we are using n and a sub n. Okay, that's basically our x and our y. And then when we have to substitute a term in, because they've given us a term, like they've given us a point to write the equation of the line, that's when we use k and a sub k. So that's what's happening here. A sub n is just y. A sub k is your y1. D is your slope. N is your x, and k is your x1. So if you look at the forms, they look very, very similar, and it really is just the same thing. Just that the lines on the right are continuous, on the left is just the discrete data that we're plotting. Okay, everybody okay with that? Then with geometric, again, because we are getting into exponential, we, I mean, it's good to know this, but you don't have to. If you're only going to know one, we want it to be this. Again, over here, we're using x and y, obviously, and then also x1, y1, and this one right here. A times b to the x should be a familiar look for you for exponential. Although we are just now getting to where we're going to start talking about exponential, they're not new. You've been doing it for a long time. That should not look brand new to you. You can replace b with r because that is the common ratio. And then you can use r in both of them. It's really the same. It doesn't matter. But if I don't have my initial value, which is A, then I can use another point to write it, and it looks something like that. Okay? Where again, over here, your ordered pairs are N and G sub N, and then K and G sub K. So trying to relate geometric sequences to actual exponential functions. And then I'm also going to show you when we get to the back how you can look at the arithmetic and geometric sequence equations and understand the commonalities between them, and it'll help you.
I'm sorry.
You're fine.
So Raphael,
Yes,
just a second.
absolutely.
He's in so much trouble.
I bet it.
Yeah.
I knew this day was coming. All right. It is important to recognize and understand similarities and differences between linear and exponential functions. Okay? So, linear functions. This is basically your y equals mx plus b. Over equal length input value intervals. Remember those words? Okay? Equal length input value intervals, no problem. The output values change at what? Change at a what? What would you say? Constant rate. Good. Change at a constant rate. Constant rate of change. All right. And the exponential functions, which this is your little generic one, again, over equal length input value intervals, the output values change proportionally. You can say proportionally or proportionately. They're different words, but they kind of mean the same thing. It doesn't matter. So if you see like a different form of that word, it means the same thing. All right, so then the change m, which is your slope, the change in y is based on addition, because we're adding. And that's why we have a common difference, because I can add 3 every time, or add 5 every time, or whatever. And then the change b here is based on multiplication, because we are multiplying by the same thing every time. And with those formulas that we have, and this isn't true for every function ever, but for these, if we have 2 points, that's all we need. Okay? We've always known that you only need 2 points to make a line. We can write the equation, but that's true for exponential as well. So, and then you can write an equation of a linear function, exponential function, arithmetic sequence, or a geometric sequence. Okay? Everybody good so far? Just kind of a compare and contrast. All right, so I spent a lot of time on the front respacing things and giving us more room to write, and I should have done that on the back too, and I didn't. So I'm just warning you, when we start writing here, we might want to write kind of small, and we probably want to, like, I'm going to make myself a line straight down here, so I know where I have to cram my answers in. Sorry about that. I've got a fix for that on the assignment, though. Oh, I guess I need to see the directions. So this says, selected values of several functions are given in the table below. For each table, determine if the function can be linear, exponential, or neither. So remember those first words that were there. It said over equal length input value intervals. Now, when we were doing sequences, it was changing by 1, because that was our whole numbers. That isn't necessarily, these are functions, not the sequences, so we're not necessarily changing by 1. But we do want to see if it is constant. So, and here's a reminder, because some of y'all were still subtracting backwards. I do not do 0 minus 3, or just whatever I feel like is easier. I do 3 minus 0, which is 3. Then I do 6 minus 3, and I get 3. And 9 minus 6, and I get 3. And then I get 3. So I have equal length input value intervals. Check. And then I'm going to have to check either for common differences or a common ratio. So before I just start doing things, like if I was just checking for linear or quadratic, I know I'm just looking for differences. But I don't want to have to write out a bunch of stuff and then write out some more. So I think ratios sometimes are the easiest ones to check first. If I do 5 over 7 and 3 over 5, those are not the same, right? So clearly not proportional, so let's just go with the differences. And when I do the differences here, 5 minus 7 is a negative 2. 3 minus 5 is a negative 2. 1 minus 3, negative 2. Negative 2. Okay? So do you think, we already said we don't think it's exponential. Is this linear? Yes. Okay. So I would say that, I'm going to say linear, and then I have to explain, and this is why we don't have a ton of room. Linear over equal, I can't even spell it right, equal length input value intervals. Okay, so over equal length input value intervals, because that was the first thing we checked. Output values change at a constant rate. And we're going to say at a constant rate of, and then we're going to say what it is so we can talk about slope a little bit again. We don't necessarily have to find the slope on each one. We can tell that it is changing at a constant rate. But my constant rate of change is not negative 2. It would be negative 2 if these numbers here were all 1. And the reason that would happen is because I would put negative 2 over 1. That's my rate of change. But they're not 1. So this is, even though this is constant, that's a constant difference that tells me there's a constant rate of change. It's not my actual constant rate of change. Does that make sense to you? But to find it, it's super easy. I just put negative 2 over 3, since they're all the same, and it's negative 2/3. So it's not difficult to find. I don't have to do any more work. Just make sure you know what the numbers mean that you have and that you're looking at. Okay? We good on that? Any questions at all? All right. Let's move on to the next one. Make another little line again. Okay, so here then, this is 1 and 1, 1 and 1. So therefore, if this one becomes linear, the differences I get, that would be my slope, right? Now when I look at this, let me just think ratios first. If I put 1 over 0, what does that give me? Undefined, okay? Undefined. So 4 over 1, clearly not undefined, so it's not the same like 1 over 0. That didn't even make any sense, right? So I'm not going to do ratios. I'm going to do differences again. So 1 minus 0 is 1. 4 minus 1 is 3. And then 5, and then 7. Okay, so is it linear? No. And we also decided it is not exponential. And those are the only two things they're asking me about right now. But can you tell me what this is? It's quadratic. Because if I do the second differences, I get 2, 2, 2, 2, 2, right? Which means my second differences are constant. That makes it quadratic, right? That's an answer for a different question, but just want to remind you that we got to remember all that stuff. So in this case, these are my only options. Linear, exponential, neither. So my answer is neither, right? So I'm going to say neither. And then here's my explanation. Starts off the same way. Over equal length input value intervals. Okay? Over equal length input value intervals. And we talk a lot about X and Y, but making sure we're using the words input and output is important because that's going to help us writing an explanation, one of our FRQs. They seem to prefer that wording, because and obviously it's not always X and Y. But okay, so over equal length input value intervals, output values, because this is all about how do your output values change in relation to your input values, right? Input values are not changing at a constant rate or proportionally. And I apologize again that you don't have a lot of room to write. What questions do you have? We good? All right. Now we're not going to make another line on the next one. I'll tell you why in a minute. Because we're going to give ourselves a little bit more room to write here. So again, I'm going to look at the inputs first. So this is 2, 2, 2, and 2. So that's all fine and good. Then, even though I said, you know, hey, looking at the ratios are pretty easy to do, sometimes glancing at it, you can tell that if I do 16 minus 8, whatever it is, it's not the same as 2 minus 1, right? So I might as well not even try my differences. When I do the ratios, I have to do the ratios in the correct order as well. Okay, because if you look at this, you might say, oh, look, I'm just doubling the one before each time. But make sure that you are, again, thinking about it the right way and see that I'm going to do 2 over 1, that does give me 2. 4 over 2, that does give me 2. 8 over 4, that's 2. And that's 2. Okay? So then I can say, and we can use up, you don't have to write quite as small. You can go into this one. We're not going to write anything underneath this one. I'll tell you why when we get there, but just letting you know you have a little bit more room to write so you're not cramming everything in there. What is this? Exponential. Good. So this is exponential. And we start the exact same way. Over, equal, and you can use all that space underneath there if you want to. Length, input, value, intervals, output values. Right? I mean, everything we just wrote after the comma is literally the exact same on every single one of those. So over, equal, length, input value, intervals, output values are changing, or you can say change, I guess. Change. How do they change? Proportionally. Good. And here we're not going to put our how they're changing because these are not, we're not counting by ones. For a line, it doesn't matter which 2 points I pick. I'm going to get the same slope every time. On an exponential, it does. And that reminds me, that was something else I was going to point out. So this is your notes from yesterday. You don't have to get them out. But we did an example where we had to find r, right? And so we knew that this was 8 and then this was 4, so we just did 4 over 8 and we got that. But if this point was missing, if this point was not here, well, can't make a circle, but if that point was not there, I could not use this one and this one, because then I'd put 2 over 8 and that'd be 1/4 and that'd be wrong, right? Since they're not successive, it doesn't give me the right thing, so I can't use that. When that happens on a graph one, because all the graph ones we did, we were able to either count the slope or get that from the graph, then I would just use this point and whatever other point I knew for sure, and then you're just going to work it like the questions where they give you 2 points and don't give you the r value, okay? And then just go from there. So make sure you're not making up math. Also along those same lines, if you checked your pink worksheet already over there, you probably need to recheck it because somebody pointed out a mistake like 2 days ago and I hadn't fixed it yet. And then after school, there was another one and I went to rework it and then it was just all kinds of wrong. I was like, I don't even know what I did on this one. So then I checked the whole thing and something else on the back was a hot mess. And so I redid it all. So it's correct now, I think. But that just, again, is a reminder that if we ever go over there and something doesn't match, yeah, chances are pretty good that maybe you made the mistake, but I could have made the mistake too, because I'm definitely not perfect. All right, so anyway, they change proportionally and then we're done. Okay, everybody good with that? All right, so we are going to do this last one. I look here and this is 5, 5, 5, 5. So I have equal length input value intervals, which is the first thing I check. Then if you think, okay, well, look, I'm just dividing this by 2 every single time. That's a fine and wonderful observation. However, notice that this says the change is based on multiplication. It does not say division. So we don't talk about how we're dividing. Just like here, we don't talk about how we're subtracting. We talk about adding a negative number. So here, instead of looking and thinking that way, just do the same thing you do. 40 over 80, that gives you 1/2. 20 over 40, that gives you 1/2. And then you get 1/2. And then you get 1/2. Right? So dividing by 2 and multiplying by 1/2 are the same thing, but we are referring to everything as multiplication. And so then this one would basically have the exact same explanation. That's why we weren't going to write it twice. It's not necessary, especially when we don't have enough room. Okay, everybody good with that? Questions? All righty. All right, so then we have, okay, so this question refers to Mr. Passwater. And I don't think I have mentioned Mr. Passwater yet this school year, and I kind of feel a little guilty about that. So Mr. Passwater is a phenomenal teacher. He's been a phenomenal calculus teacher for years and years and years. And then last year he taught AP Calculus and AP Pre-Cal, first time for him, just like literally everybody else. He teaches in some school up in Indianapolis somewhere, I don't know. But he's done calculus training and written calculus curriculum and been very helpful in the calculus world, and he's like a College Board consultant. So he's really like he's kind of a celebrity in the calculus teacher world. And obviously now in the AP Pre-Cal world as well. And one of the phenomenal things that he does is he writes really great curriculum. And most people that do that, or actually people that write curriculum, it could be good or it could be total crap, they sell it, right? And they try and make a lot of money. He doesn't sell anything. He just freely gives it to any teacher that wants to use it. He welcomes feedback, answers questions. I can't even imagine answering some of these questions that I've seen people ask him, like adults asking him. But anyway, so he is phenomenal. So at the beginning of the year last year, when we were all starting, we all kind of had nothing. We did, as a district, buy a specific curriculum for us to piece things together. And I was the one that suggested that because this particular one, I knew she had written calculus curriculum that a lot of people, we didn't use, but I knew a lot of people liked it. So I was like, well, it wasn't aligned to the AP stuff hardly at all. And a lot of people kept using it, like in our little groups, and I was kept thinking, I don't know, have y'all really looked at what that stuff is? And she started fixing things along the way, but either way. But Passwater had his stuff in there because he was actually teaching it, and he would edit it along the way. But again, he was freely giving it to everyone. And I think that his assistance and just being so selfless and all that was really a huge help in my students' success rate last year. Yes, I was up here teaching it, but without his materials, I don't know that I would have done as good of a job. So anyway, I'm saying all this because I feel like I do need to give him props, even though, y'all don't even know who he is. Because what I do, though, most of the notes we use, not all of them, but most of them are at least somewhat of his that I have pieced together. I do take off the copyright stuff that he puts at the bottom, not because I don't want to give him credit, because I will give him credit all day long, every day, but because it's sometimes in the way. I just feel like it's always in the way, so I just take it off. But anyway, so when he writes questions and he puts himself in there, I just leave him in there because we just need to honor Mr. Passwater and be very thankful for him. All right, so anyway, a wild rumor is spreading that Mr. Passwater won 3rd place in the world's strongest man contest. Mr. Passwater definitely, probably, didn't start the rumor. The number of people that have heard the rumor can be modeled by using a geometric sequence. So right there, I'm going to pause. And before I get any other information into my brain, I'm going to say, okay, clearly I'm going to have to write a geometric sequence. So without looking at anything, I want you to do your best to write down your G sub n formula that we wrote 1,000 times yesterday. See if you can dig it out of your brain. And then if it's not correct, we can adjust it before we go on. This is how you use your reference materials as a tool and not a crutch. You are using reference materials as a crutch if you look straight at them and just use it, or if you look straight at them and copy them down. You're using it as a tool if you try to write it down on your own from your memory, and then you use the reference materials to check yourself, especially with stuff that you're not going to be given. So G sub n is equal to G sub k times, sorry, at this moment that, okay, I was geometric, R times n minus k, right? So if you wrote that down correctly, you can pat yourself on the back. If it wasn't perfect, fix it and it'll get better. All right, so we're going to continue to read. Where 43 people had heard the rumor on day 3, 140 people have heard the rumor on day 6. According to the model, how many people, to the nearest whole number, have heard the rumor by day 10? All right, so I need terms, right? They didn't give me R, because I don't know R here, but I do have enough information to get 2 terms out of here. So do you think that X, what is my N? Is N the people or is N the days? Days, because as days increase, right, then the rumor is going to increase exponentially. Okay, good. So I'm going to write down this. Let's see, 43 people, day 3. So that means G sub 3 is 43, and G sub 6 is 140. Okay? And I'm going to use those to find R. In order to do that, I need a G sub n and a G sub k. So remember, we're looking, these are in order. So I'm going to make this G sub k, this G sub n. Then I'm going to fill all that stuff in over here. G sub n is what? 140. And that's equal to G sub k, which is 43. I don't know R. N is 6 minus k, which is 3. Okay. And remember, we put them in that order, so we get a positive exponent up here, not a negative exponent. All right, so then, am I going to divide by 43 or subtract 43? Divide. So I'm going to divide. I'm going to get 140 over 43 equals R cubed. Now, it's probably better that we couldn't get this stuff, your computers, to work, that I'm just going to show you stuff anyway. So if I do over here 140 divided by 43, if this is a calculator question and you're allowed to use the calculator, you absolutely, positively would never, ever, ever take this number right here and then write that down to 4 decimal places and keep going with the problem, okay? You have to have, you cannot round until the very end. So you never, ever, ever like type back in a decimal that you get. You either have to store it, go back and figure out how to use it. We'll get to all that stuff. Or you keep it exact. And so if I hit this, it reduces my fraction that clearly doesn't reduce, right? So instead, we're just going to leave it like that for right now. We good? Okay, so keep that in mind. You do not find it. We never change fractions to decimals. That's a hard no on that. You will get wrong answers. Every now and then, maybe you get lucky enough you're right to 3, but don't do it. All right, how do I undo a cube? Cube root. So that means that R is equal to the cube root of 140 over 43. Or, and if 140 over 43 gives me a crazy decimal, the cube root's definitely going to give me a crazy decimal, right? So I definitely don't want to even, I don't even have to type that thing in. I can also write this as 140 over 43 to what power? 1/3, okay? And so that's what we're going to do now. We could leave it as a cube root. We're going to go ahead and put it as a fractional exponent because that's going to lead us to some other things down the road. All right, so then now we are going to fill this in. I have already used this to help me find R. I'll just get rid of it. So G sub n is going to equal G sub k, which is 43, times R, which is this weird old 140 over 43 to the 1/3 power to the n minus 3 power. Okay? This would definitely be a calculator question, so don't freak out, but you still have to leave it like this. Like, whether you have a calculator or not, it's still going to look like this. It doesn't even matter. And there's your G sub n. Okay? We could do some stuff with those exponents, but we're not going to today. That is something that we're going to get to where we're manipulating those things, but like I said, not today. We're not ready for that just yet, so we can just leave it like that. And then I'm going to find, it says day 10. So I need G10. G10, and that's going to equal 43 times 140 over 43 to the 1/3 power to the 10 minus 3 power. Then I could just type all of that in the calculator. I could either do 10 minus 3 or I could do 7, but the rest I would just literally type it in like that. And both sets of parentheses are important. Because remember, if I don't put this one around here, then I'm only taking 140 to the 1/3 power, and that's not what I'm trying to do. So when we do this, because I think we are all capable of typing that in, hopefully, then I'm just going to tell you what we get. We get that G sub 10 is equal to 675.5758. But it does say, according to the model, how many people, that's kind of a giveaway there, to the nearest whole number have heard the rumor by day 10. So do you think in this case that we would round up or round down? Okay, I kind of heard both. Let's talk about both here. We're talking about how many people heard a rumor. And it does say to the nearest whole number, which technically would make it 676, right? But if we were talking about, I always use how many people on a bus, that'd be a really big bus, but how many people fit in a room or fit in a building? If we're looking for how many people actually fit in this room, and that's the number that we get, would 676 people fit in this room? No, because you're not going to have half a person, right, Anne? Right? Yeah, of course. You would have to round down. So it kind of is the context of the question, and this is one of those questions that comes up a lot in some of those forums, like, what do you tell the kids which way to round? Because we know our rounding rules, at least we should, but then you also have to think about what makes sense. I think in the rumor sense, it would make 676. What I have seen on well-written tests that are like high-stakes tests is that if something like this happens, and we're talking about people, then usually this part of the number, you kind of wouldn't have to make a choice. Like it wouldn't be a round up, wouldn't be an option. It'd be like a 0.3 or something, and then we'd know to round down. You with me on that? So that's just kind of a, but here's what I would do if I was taking a test like this. And I'm like, what am I supposed to do? Round up or round down? I'm going to make the best decision, but I'm also going to have this written down. Like this is not my answer because I can read the directions, but I'm going to show them I know how to do all that stuff, which is really what we're testing, right? I know how to do all that stuff. This is what I get. And then the answer to my question, I think 676 would probably make sense here, plus that's kind of what it says. My answer is 676 people. I definitely wouldn't leave it like that 675 because it does tell me to round it. Okay? But if you get all stuck in the which way do I do it, don't try to overthink it. Write the decimal down, make the best decision you can, and I think you'd get credit either way. Okay? What questions we got? Because again, when it comes right down to it, this is not what's being tested. It's all the rest of the stuff, right? Okay. Now we have a large theater, has rows of seats. Okay. A large theater has rows of seats where the number of seats in each row can be modeled by an arithmetic sequence. So we're going to pause right there. It's been a couple days since we did this without looking, although some of you are already cheating. A sub n equals, and try to write it down from your brain the best you can. Think about what it relates to, what it looks like, because you have to learn this. And then we'll check ourselves. All right, A sub k plus d times n minus k. Right? If that's not exactly what you wrote down, adjust what you have. Remember that adjustment, so hopefully you don't have to do it in the future. And then I want you to look at these two that we just wrote down. Okay? Both of them start with a k term. And then for arithmetic, we know that we have to add in that. And for geometric, we know we have to multiply, right? So what comes next is either add or multiply. And then it's either the slope for arithmetic or it's the r value for geometric. And then in parentheses is n minus k. It's being multiplied because that's what makes sense here. It's in the exponent here because that's what makes sense. So if you also look at how much these have in common, then you can it'll hopefully help you remember the order, and it's not that big of a deal to remember at all. Okay? We okay on that? All right, so then we keep reading, and it says, if the fifth row has 31 seats, 11th row has 49 seats, how many seats are there in the 25th row? Okay, so we need to find an A sub n first. What is my n value? The row number or the seat number? The row number. Okay, so A sub 5 is 31, and A11 is 49. And then I'm going to label them. 5, 11, that's in order, so A sub k, A sub n. Then I'm going to fill all my stuff in. A sub n is 49, equal to A sub k, which is 31, plus d, which I do not know, times n, which is 11, minus k, which is 5. So do I divide both sides by 31? No. I subtract 31 from both sides because that's what makes sense here. And this gives me 18 equals 6 times d. So d equals 3. And that worked out much prettier than it did for the geometric. So now I write my a sub n, which means I'm going to mark out that term so I don't accidentally use any of that stuff. And a sub k is 31 plus 3 times n minus 5. Then I want to find the 25th term to figure out the 25th row. You go ahead and work on that while I hand out the assignment, and then we'll double check ourselves. Okay, I got 91 seats. Is that what you got? Okay, good. Any questions at all? All right, so on your assignment, on the top 4, you will still don't have a whole lot of room to write, but it's only one-sided, so you can write on the back. In hindsight, I should have made this two-sided and spaced this out a lot better, but I didn't. So you can use the back. Some of you write tiny and it's no big deal, but for most of us, that would probably be a problem. And then on the ones where you get to the weird R values like what we had, those would be calculator questions. You can use Desmos on that kind of stuff so that you can get it figured out. All right, any questions at all? Beautiful.